We have already done 5 questions on motion graph kinematics. This is your question number 6. This is again a long question. It is split across 3 screens. I'll show you all the 3 screens. You can take the snapshot, attempt the question yourself, and come back. You can pause the video, come back, play the video to look at the working of it. So this is the first screen, the first part of the question. The second part of the question, and then the third part of the question. Solve the question yourself, pause the video and play the video again. Meanwhile, do not forget to subscribe to the channel if you think that the videos on this channel are relevant to you and you find them helpful. And do not forget to comment in the comment box and share your feedback, because it will be very, very helpful to me to improve on the quality of the content that you see in the videos. Alright, so assume that you all have solved the question and you are back now. You have played the video back again. Let us understand what this question is saying. Part A. A student walks from A to B along the path shown in this figure. The student takes time t to walk from A to B. State the quantity. Now the first part says, state the quantity apart from t that must be measured in order to determine the average value of the speed. So if you have to calculate the speed, and the second part says to calculate the velocity. So what is the formula for the speed? The formula for the speed is distance over time. So you already know that the time is not something that they are talking you to comment about. They are talking you to comment only about distance. So how do you measure the distance? You have to measure this entire length through which my pointer is moving. You have to measure this entire length. That's your distance. So what should be your answer? For part 1, what is the quantity that you need to measure? The quantity that you need to measure is the distance. Part 2, velocity. What is the formula for velocity? Velocity is displacement over time. So what is the quantity you need to measure? You need to measure the displacement. What is displacement? Displacement is the straight line distance between A and B. You need to measure the length of this red line that you see on the screen. That's the displacement. Displacement is the straight line separation of the straight line distance between point A and B. Right? Simple and easy question. For the second part, your answer should be you need to measure displacement. That's it. 1 mark gained. Defined acceleration. How does CIE expects you to define acceleration? It is simple. It is the formula for the acceleration itself. It is the rate of change of velocity. Or you can simply write down the formula for the acceleration. V minus u over t. Change in the velocity over the time taken for the change to take place. Let us tally with the mark scheme. I'll show you the mark scheme as well. Please look at the mark scheme, pause the video and understand how these questions are answered, because these are the kind of questions which get repeated year after year. So you should know how to define acceleration, how to define speed, how to define displacement, how to define velocity. Alright, pause the screen, go through these 2 points and understand them well. Now that we have solved the first part, let us move to the second part of the question, which says, a girl falls vertically onto a trampoline as shown in the figure below. The trampoline consists of a central section supported by springy material. At time t is equal to 0, the girl starts to fall. So where is the girl at time t is equal to 0? At time t is equal to 0 seconds, the girl is at the topmost position. The girl hits the trampoline and rebounds vertically. She hits the trampoline and she rebounds. Okay. The variation with the time t of the velocity v of the girl is shown in this figure. So you have a velocity time graph for the motion of this girl given to you. She falls, rebounds, The entire change of speed versus time is given here. For the motion of the girl, calculate the distance fallen between time t is equal to 0 and when she hits the trampoline. So let us understand what is happening here. The velocity is increasing from 0. So initially at t is equal to 0 seconds, she was at this location, she started falling. The velocity was 0. This is what we understand. Time t is equal to 0, the velocity was 0. Maybe she was standing at a platform, right, and then she took a jump. So initial velocity was 0 meters per second. And as she was falling down, what was happening? Acceleration of gravity was acting over her. So she was accelerating at a constant rate of gravity. She was increasing in speed. So if you see, speed is going up and up and up, up and up until the point she hits the trampoline. So she reaches this point at this particular time. So what is the value of time when she hits the trampoline? It looks like it is, you can read the graph, looks like this is 0.9 seconds. At 0.9 second she hits the trampoline. The trampoline then compresses. Looks like that the trampoline goes down. There is a deceleration happening, and the speed goes down to 0. Quickly she hits the trampoline and the speed goes down and she reaches a 0 speed. Now the trampoline is pushing her back. Negative speed has started coming. After this particular time, negative speed are coming. That means she is now moving upward. Starting from this point, she is moving upward. This is what it means. She is getting a push. Her speed is increasing quite at a larger rate. She reaches the maximum speed, -4. Then the speed starts going down. Why? Because she is going up slowly. Ultimately at the topmost point, she'll have a 0 speed again. So at this particular time, she has a 0 speed again. So that's how you need to understand the graph. If you do not understand it, rewind the video again and listen to what I just explained, and it should make sense to you, right? So they are saying the distance fallen between time t is equal to 0 and when she hits the trampoline. So this is the point, 0.9 is the time when she hits the trampoline. You have to calculate the distance. If you have a velocity time graph, how do you calculate the distance? It is the area under the graph. You should be able to answer this question. The theory for these things are already done. You can go through the theory video on motion to understand. This is the area that you need to find. So half times the area of the triangle is half times base into height. So half times how much is the base? 0.9 times the height. How much is the height? Let us calculate the height. You need to do some calculations here as well. This is your height. How much is the value of each single block here? Each single block is how much? 5 blocks. If we see 5 blocks is 2. So each block is 2 over 5. Each block is 0.4. Each single block has a value of 0.4 meters per second. So 2 blocks is how much? 8. So this is 8.8. These are simple things that you should be knowing about reading the graph, right? So here you have 8.8. When you solve this, you'll get your answer. Let us tally with the mark scheme. Are they also doing the same thing? Area under the line, which is 8.8 and 0.9 divided by 2, 3.96 or 4 meters. 3.96 or approximately equal to 4 meters. That should be your answer. There is another way of doing this question using the equation of motions that also you can try. We know S is equal to ut plus half AT square, right? What is the initial velocity? Initial velocity was 0. U is 0. What is time t? Time t is 0.9. What is A? A is 9.81 because everything is happening under the influence of gravity. You can substitute these values in the equation. That's a second way of solving this question. Second way, using the formula, equations of motion. Let us tally with the mark scheme. Yes, they also suggest the same thing. They have taken G as 9.81, right? Alright, done. Okay, another way, another equation of motion that you can use here is V square is equal to U square plus 2AS. You know that V is how much? The final velocity is 8.8, U is 0, A is 9.81. You can use this equation. So that's the second way, and this is your third way. So many ways of doing this equation, this question. If you have done while working this question yourself by any of these three ways. Way 1, which is simple, finding the area of triangle. Way 2, which is using the formula S is equal to ut plus half at square. Makes sense. Or way 3, everything is fine. You should be getting the same answer. If you have not tried all the three ways, you can try it yourself for your self-practice. It helps you practice, it helps you work with the formulas, and you'll be surprised that you'll be getting the same answer every time, which justifies the beauty of physics. You need not by heart anything. Only thing that you need to do is understand the concepts. If you understand the concepts well, you'll not go wrong in applying your logic, right? Let us move on to the next part now. Average. They are telling you to calculate the average acceleration during the rebound. This is the rebound. They have mentioned it as well very clearly. This is the rebound. You have to calculate the acceleration. So whenever you have to calculate the acceleration, you start by writing the formula for the acceleration. Please do remember, go through my video on acceleration to understand that there is only one basic root formula for acceleration. If you apply it correctly, you will not go wrong with your answers. Only thing that you need to understand is to find the value of v, u, and t is easy to find. So what is the value of v? V is the velocity which happens at a later point of time. Later and earlier point of time concepts you'll understand when you go through the theory of acceleration. So what is the velocity at the later point of time? This is the time which comes later, right? So later time. This is the velocity which comes earlier point of time. This is 0.9, earlier velocity. Later velocity around 1.3 or 1.4. So what is the velocity? Let us locate it. How many blocks? Looks like it is just one block. So minus 4.4 meters per second. What was the initial velocity at earlier point of time? 8.8. We had just found out in the previous question that this is your 8.8. And this is your minus 4.4. Do not ignore the signs. This is something which I have been telling you again and again. Be confident with the sign. Move on with the signs. Right? So what do you get? You get V is minus 4.4 minus 8.8. And how much is the time taken for this change? Let us find this as well out. This goes all the way up here. So which looks like, just hold on. Difficult to read the graph sometimes when it is quite, the numbers, the blocks are very small. Okay, so what is it? 1.4. Yes, it is 1.4. So this is 1.4 minus the time here was 0.9, 0.9. Solve this and you should be getting your answer correctly. Let us look at the mark scheme as well. Are they also doing the same thing? Yes, precisely the same thing. You get an acceleration which is coming out to be a negative number, negative 26 minus 26.4 meters per second square. Alright, understood? For any doubts, please comment in the comment box and let me know your feedback if you're finding the explanation helpful. If you want me to include, or if you want me to increase the speed or decrease the speed of my explanation, please write about it, comment about it and let me know. So C part, use this figure to compare without calculation the acceleration for the girl before and after the rebound and explain your answer. Let me erase all these data now, it's not required. Before the rebound, which part of the graph they are talking about? This part. This is before the rebound. After the rebound means which part of the graph are they talking about? This is after the rebound. Alright, so you have to compare them. You have to compare this section and this section of the graph. What do you see? They are straight line. So one of the things that you can say is they are constant acceleration. Constant acceleration. Constant acceleration, 2-mark question. One of the marks you will get for writing that they are constant acceleration. And if you notice, they are parallel lines. They are parallel lines. What does it mean? They have the same gradient. Whatever is the gradient here is the gradient here. Same acceleration. Gradient on a velocity time graph means acceleration. So same acceleration. Same acceleration and the constant acceleration. And what should be the value of the acceleration? Did you ever think about it? You can think about it as well. Everything is happening under the influence of gravity. So the acceleration value should be g. That's also one thing that you can mention, an extra point that you can write in your answer so that the examiner knows that you have the knowledge, right? Here is the mark scheme. Refer the mark scheme, pause the screen and refer the mark scheme. This is precisely what I have just explained. Alright, let us move on to the next question now. Use this figure to compare without calculation. Again, without calculation, the potential energy of the girl at t is equal to 0 and t is equal to 1.85. So t is equal to 0 and t is equal to 1.85. So what is the position of the girl at these two locations? At t is equal to 0, we had identified that the girl was at the topmost point. And at t is equal to 1.85, this is the point they are talking about, the girl rebounds and reaches the topmost point. This topmost point, is it the same as the earlier topmost point or lower than the earlier topmost point? You have to find out. So let me say again, at t is equal to 0, the girl was at the topmost point. She goes down, rebounds and reaches the topmost point at 1.85 again, right? So but this new topmost point, is it the same as the earlier topmost point or is it lower? It cannot be higher, it can be the same or lower. That's what you have to find out. How do you find out? It is found out by calculating the distance. The distance. S means distance or displacement. How do you get the displacement from the speed time graph? Area under the graph. So the area under the graph when she was coming down is greater as compared to the area under the graph. This triangle has a smaller area. When she went up for the second time, it's smaller. So that means her topmost point after the rebound, this area is smaller, is lesser. Distance traveled was lesser. She lost some energy, maybe as sound or heat, when she was colliding with the trampoline. Therefore, she reached a lower height. So when the height is less height is less, what happens to the potential energy? Potential energy is less. So what should be your answer? You should be saying that she reached a lesser height after the rebound. So let me write down what should you be writing. Just hold on, let me change the. So the girl reached a lesser height after the rebound. How do you prove this? This is evident because the area of the triangle below the x-axis is lesser than the area of the triangle above the x-axis. Hence what you can say? Hence we can say that her potential energy was lesser at t is equal to 1.85 seconds as compared to her PE at t is equal to 0 seconds. So this should be your answer. The girl reached a lesser height after a few mistakes here and there. The girl reached a lesser height after the rebound. This is evident because the area of the triangle below the x-axis is lesser than the area of the triangle above. The area of the triangle represents the distance moved. Hence, we can say that her PE was lesser after the rebound, which is t is equal to 1.85. You had to compare these two times, right? As compared to her PE, at t is equal to 0 seconds. This should be your answer. You can read the answer and understand it. I'll show you the mark scheme as well. There are other ways of proving this answer as well with respect to the kinetic energy. Go through, that's another way of proving. Go through the mark scheme and see if you understand it. If you do not understand it, do not bother about it. But if you want to understand and know how you can explain it in terms of kinetic energy as well, even after going through the mark scheme, if you do not understand it, ask me in the comment box. I'll explain it to you. Alright, thank you so much then.